Hello, everybody. Today, let's quickly look at a paper that I drafted in 1997 when I was at Nanyang Technological University in Singapore. But the content of the work was part of my thesis completed at Huazhong University of Science and Technology in Wuhan, China in 1996. So the subject is diagnostic expert system for power plant boilers. This paper has never been published. I only share that with colleagues and friends in person. If you have an interest, you click like and subscribe or contact me. So I can share this with you. So the keywords. This is about the thermal power plant and boiler in particular. Look at the fault diagnosis. The flat imaging is one of the sensing technique we use, and the related artificial intelligence. We've been I won't say crazy, but we have high interest in AI recently due to ChatGPT and GPT-4, maybe GPT-5 as we move forward. And it's a real-time system we try to build. And that time we just start using Windows programming. We're moving from DOS system to Windows programming. So that's around 1995 and 1996. That's the time. So this is content of the whole paper. This is a generic introduction and the background, and there's some literary review information. And this is using object-oriented method to analyze the boiler force. So we're gonna look at that with detail later. So that we look at the measurement and sensing and data acquisition system. So in section 3, and this is knowledge system using both rule-based and the neural network method. We're gonna walk through that quickly because if you wanna read, you're gonna get whole paper. Send me email and we can I can send this with you. Although this is not published, but the copyright of the thesis is protected by Huazhong University of Science and Technology. But that's in Chinese. So, and then there's section 5 is about the software prototype we developed using Windows programming. So this early work is kind of uh, I won't say pioneering, but we're pretty much the early users of Windows programming using Ball and C at that time. And then today, programming with ChatGPT, we can do it better. So, and then we have a conclusion. So we walk through that quickly. So again, we have this title, and I still put the affiliation as Department of Power Engineering at Huazhong University. Today is it's the School of Energy and Power Engineering of Science and Technology. And this introduction and why is this important. So it's like any paper, they got the survey information and the summary of all the work here. And we already walked through the content, so we don't have to go into that. So here, as we move into the second part, let's look at the analysis, boiler force, the diagnostic strategies. General, this one provide the over a view of this boiler for detection and diagnosis system. And in general, it can be applied to a generic system, object system, as an industrial system, put this way. And you got the human senses is the operators, and you got different sensing approaches, energy or material like emissions or this energy like optical vibration or temperature, pressure, all this, and you get all the information. DCSs will capture that, but you can have engineering station to take extra informations, and then you got a feature creation like what we call data analytics part, and extract the useful features, and they use a pattern recognition for normal for detection of abnormality or classify force of different types or help do root cause analysis further to diagnose the real cause and give advice on operations. See that goes back to this is the whole thing. This is a generic approach. So the main force, this is we use a strategy like view system is a structure, but also is functionally there's a functional architecture. So we're gonna look at the later. So this is more most like a generic discussion. You can look later. So here's in particular look at the when we look at the boiler combustion diagnosis, we look at this is signals. There's optical signals, flame imaging. Uh, so there's DC versus AC. We're gonna do sensing differently, and we do quantitative call analysis. We do image or visual feature extraction in spectral domain. Spectral domain means they just process that as the image to the image, or you're gonna transfer that from spatial domain to frequency domain, or use wavelet to transform that into spatial fractal domain, like you transform time series into frequency domain or time frequency domain. So it's a similar approach, but the image is a 2D. If you apply visual, that gives you 3D, but you can still project that into the frequency domain or spatial frequency domain using different method. Later, you can look at for image visual processing, you have a bunch of methods. So also you can recall that like a flame scanner is gonna got a time series, and you do frequency analysis. Yeah, and you can just do statistics analysis, do pulse scribe, basically you do FFT, Fourier transform, or you can transform that into wavelet analysis as I presented in the other paper the other day. So there's a lot of method you can apply. So what is this is this better data acquisition system that the lab used basically Dr. Joe used as when he was doing his postdoc work. I was part of his team in that NS project. So this is early, that time CA 630 image board acquired that, or the lab acquired that from Beijing NS Automation Institute. This cost $17,000 RMB. I mean Chinese dollars at that time, pretty expensive. So and today it's much less expensive. It costs much less. So and we can have abundant emissions. So but the philosophy is the same. You're gonna capture the image or video, and if you got abundant information, how you gonna take advantage of that? That's a question you put on the table. And there's the early times. That this is the lab testing work that Dr. Joe and the team finished. Is a temperature control, and you can convert that into 2D dimensional temperature distribution, and this is probably information which you can use fit into the expert system. So then we look at the knowledge system. What is knowledge system? Then we look at it's basically a system like a boiler or power plant. You got the hierarchy of structures, right? So object, structure, object, and there's a functional, and look at the four types: flint failure, explosion, implosion, or slugging, or all kind of things. And these two, the physical structure versus the functional force, how they can integrate together. I mean, today in today's software, I mean, we try to use the object-oriented method to organize the whole thing. And at that time, we tried to apply the same philosophy to this. So, and this is the image. Basically, this is a generic boiler image. That early time, there's a PhD thesis from Tsinghua University. His name Dr. Yang Li-Ming, who did the early work on boiler water steam site for diagnosis access system in early 1990s. So, and this is a flint failure. Basically, we derived from the recorded failure types. So and this model basically this is from the early time from Professor Zhang Mingchuan. As yeah, it was at least here in reference from his PhD thesis. He did the PhD when he was already a senior engineer in Xi'an Thermal Research Institute. He completed his thesis in Tsinghua University. So and then he was a professor at Shanghai Jiaoteng University. He retired from that. So yeah, he's a great person to work with. Basically, it's a sign. Oh, but this will give an idea how we can use incorporate mathematical models into the whole big picture of fault diagnosis and monitoring, besides the rule-based knowledge or neural network, what we mentioned later. So, expert knowledge talk about the all the things. There's a rule-based things, but here in particular, we talk about how we can use neural network to model the process in incorporating all the different data, so that like a code analysis of structure of the boiler and operating data, and fuse all these informations and to predict the behavior of slagging tendency. So this is pretty early. Remember this was first generated in 1990s. So even today we don't have a full realization of the neural network for such a purpose. So um, but this is a good model, I believe. So and then we talk about the rule-based system. So rule-based if-then, and this is the first generation expert system, and one of the problem is called combination explosion. So if you combine all these rules for a complicated system, you may have too many rulers, and the searching become tedious work, and you may not get the inference most efficiently. But um, and then we look at how to. We're gonna skip it. This is basically how you're gonna do the inference. This is the method you can find in the other references and textbooks today. So rule matching and calculation, this is the thing. You can do this basically how you're gonna do the calculations, and then this algorithm for searching. But let's go to all this. This is then we build the rule-based knowledge management system. You get a rule-based symptom force, a dictionary, and inference. You do interpretation, and you can help. It's like a small prototype of a knowledge management system with a Windows user interface. I did not put uh, the the screenshot here, but in the thesis I did put that. So okay, so and then to deal with the 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 problem with the rule-based access system, uh, we developed this method. By saying we is my college friend, Dr. He Yaopa, and myself. We try to use neural network to train the rules. So we built a rule base, but and then we train that, compress that using neural network, and so that I mean, this is an example. It's only a few rules, but think about it, you got 1,000 rules, a million rules like today, for uh, uh, very complicated systems. So it's neural network basically you control that. Can train and compress the information. It can be trained to compress the information and learn from the knowledge you fit in. So it's pretty much the same philosophy. We train, or people train. OpenAI trained the Chat GPT model, huge model, or the latest model for GPT-4. Yeah, it's the same philosophy. You got all the structured, unstructured knowledge, and text information or numeric information, and later use visual and audio information. You train them, and then the neural will become very knowledgeable. And you got a mechanism to extract information to get what you want. That's the engineering prompt part. So, but this is the early stage. Remember, this is 1990s, about even 30 years ago. So technology really evolves. So at that time, hardware, software, and full understanding does not reach the level of today. But you see how all the things evolved. So And then there's neural network. We build similar to that rule-based expert system. We build this neural network knowledge-based management system using the Windows programming. Yeah. So this is good. So this is and then we develop the sensing technology. We evaluate the rule-based method, neural network methods, and also organize the force and with physical systems, uh, and uh, and then we built this pseudo, I wouldn't say online monitoring. It's not really online. We just read the data we store and try to run it in the Windows system. At that time, it's pretty early. We use remember this does not exist anymore. We use a Ball and C, C++, Windows 3.1 for developing Windows interface. But it's better than using Turbo C 2.0 and build all the interface. I did that earlier for my master's degree for computer-aided design software. It's kind of painful because you have to manage the storage at very low level because you're gonna allocate memory and the release free the memory. If you don't do well with at that time the 286 machine or 386, and you're gonna memory overflow and the machine will die. So today you don't have that problem. You don't have that problem. But still, well, and when we moved to Windows programming, Microsoft to try to manage all this and make it better. And today, when you do a high-level programming, you don't worry about the hardware and low-level programming issues. So you see how over the past 20, 30 years, how technology evolved. And the early time dreams may come true in today with today's computational resources. And we should rethink the dreams that we had before early time and how we can apply the most advanced technology we have today and maybe of dream of yesterday or many years ago may come true, become reality for today. That's why I want to explain this to you, not just to, oh, there's a historical science, historical work I've done 30 years before, 30 years ago. So, but think about all that we could have good thinking or good ideas, but resources not available, conditions not ready, environment that does not allow to achieve breakthrough. But today, with another wave of AI and technology, or the technology breakthroughs in all kind of fields, in particular computation field. So what we can do, evaluate the old ideas we had, the bottlenecks we have, and with today's technology advancement, so how we can make breakthroughs and bring blessing into the field we are placed in. So that's something. In this paper, you not put the the Windows interface, but that's not this is shows to say something the structure of a functional system. But if you go back to the thesis in Chinese, you can see everything. That's only maybe applicable to people who can read Chinese. So, but yeah, this is a structure to tell you how we develop this window-based system for monitoring. You read the data, do an access initialize, and it uses MDI monitoring because you're going to show multiple windows. So at the time, it's and they use executive kernel. Yeah, you're gonna use knowledge base that you can fit embed in under this, and you do analysis, interpretation. So good thing is we've been early times we've been talking about the interpretation. We start working on both rule-based and neural networks. So we fully realized the pro and cons of both methods from rule-based symbolism versus neural network connectionism. And today we still have the problem how to best interpret the inference process and the logic the machine uses in ChatGPT or GPT-4, 5, or Google's machine learning models they're gonna put on the market. So, okay, this is a quick talk, and if you want to look at this, I can put down link in and so that you can access this, or you can add comments. So I can share this with you. The again, this is English, but it's translation uh, 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 from the original work in uh, the PhD thesis completed at Huazhong University of Science and Technology. So the university protects the copyright and the work of this. So, but it's 30 years ago. So it's really about 30 years ago. So it's something I want to bring about and reflect what the dreams we had before and today when we have all the advanced resources and computing breakthrough technology. We so how we can reevaluate the methods we tried to apply before or the dreams we had before and see how we can uh, uh, achieve better results in today's environment and add the innovations to today's industry. So, yeah, if you have the same thoughts or you feel you want to communicate, just comment. Thank you.